So this is problem 77, chapter 10 of Giancoli 6th edition. So what we have is a piece of wood that is floating in water. Okay, so let me make my drawing here. I have this piece of wood which floats in water. Now on top of this piece of wood, and they give us the mass of this piece of wood, they give us the density of wood. On top of this piece of wood which floats in water, we put another object, we put a mass of copper. Okay? So here it is, the little piece of copper. And once we put the copper inside, well, this whole system goes a little bit down, and the whole piece of wood, so this is our piece of wood, the whole piece of wood gets submerged in the water completely, but the system still floats. Okay? And the question of the problem now is, what is this mass of the copper that we put there and still floats in water? So the whole system still floats in water. That's the question. Okay, the density of water we know. We assuming here water at 4 Celsius, so we know that the density of water is 10 to 3 kilogram per cubic meter. What do we have here? We have the weight of the piece of copper, and we also have the weight of wood, all that being carried by the buoyant force. Okay, so let's go for the equation. What we have is that the buoyant force is equal to the weight of copper plus the weight of the piece of wood. Okay, now the buoyant force is the mass of the fluid multiplied by G, and the fluid here is water, and the mass of the fluid is the amount of the fluid that was displaced so that this whole piece of wood could fit inside. Okay, so I can rewrite this mass of the fluid. I don't know what this value is, but I can rewrite it in terms of the density and volume. So this is the density of water, which we know, multiplied by the whole volume of the piece of wood. Okay, this is multiplied by G. The other side, I also have the mass of the wood multiplied by G plus the mass of copper multiplied by G. So this G just cancel. All right. Now the mass of wood is given to us. Okay, so this we know. And what we want to find is the mass of copper. All right, so I'm going to isolate the mass of copper. The mass of copper will be then the density of water multiplied by the volume of wood minus the mass of wood. Okay? And here almost everything is finished. The only problem that we have is the volume of the wood. This one was not given to us. Well, not such a big problem. We can write the density of wood again using the expression for density. Density is the mass divided by the volume. So instead of writing the volume of the wood, I'm going to write it as the mass of the wood divided by the density of the wood. Now I'm good because now I have everything. And so the mass of the piece of copper, which is our unknown, is equal to the density of water, which we know, the divided by the density of wood multiplied by the mass of wood minus the mass of wood.